In the next few videos, we are going to learn what the sine rule is and what the cosine rule is, and how to use those two rules to find sides and angles in triangles. Triangles that are not necessarily right triangles. We're starting with the sine rule, and let's just begin by finding out what the sine rule is and how the rule was discovered. We're actually gonna discover it right now as we go. This is a triangle. It's triangle ABC. This is not a right angle. You can tell it's slightly smaller than 90 degrees. ABC, and the thing that we do when we label these sides and angles is that if this is angle A, we're going to call this side, the opposite side, A. If this is angle B, we're going to call the opposite side, small letter b, side B. And the side opposite of angle C, we're going to call C with a small letter. These are all capitals because they're angles, and these are small letters. Each side is opposite of the corresponding angle, C, C, A, etc. All right. In order to be able to say anything about these sides and angles, we are going to draw the height of this triangle in here. We are drawing a line that is perpendicular to side C. Excuse my broken ruler. This we're going to call H because it's the height of this triangle. It's at a right angle with the base because that's how we drew it. This gives us one new point that we can look at as an angle. There's an angle on this side, it's a right angle. There's an angle on this side, which is a right angle. We'll call this point Y. So C is the length of this entire side. Y is this point, and actually this angle on this side or that side. We now have two triangles, really. We have AYC. AYC, it's a triangle. And we have triangle BYC. Triangle BYC. Together, these two triangles make up triangle ABC. Okay. Let's start off by looking only at this one, AYC. There's an angle A here. The sine of angle A, what is that defined as again? Remember, TOA, everyone remembers this differently, but so stands for the sine is the opposite side over the hypotenuse. So in angle A, the opposite side is H. So H over hypotenuse, and the hypotenuse is the side opposite the right angle, which in this case is B. So the sine of angle A is H over B. Now if we want to make H the subject of this equation, we multiply both sides by B, and now I'm going to flip sides. It gives you this. You can pause the video and check me if you feel the need to. But we can switch this around, make H the subject of this equation. Now let's look at this other triangle, BYC. The thing that these two triangles, this triangle and this triangle, these two triangles have in common is that is this side, H. It's in this triangle, it's also in this triangle, right? They have H in common. But let's look at angle B. And the sine of angle B, once again, is opposite over hypotenuse. Opposite, in this case, is also h. It's opposite the angle. Divided by hypotenuse, the hypotenuse is a. Now if we change this around to make h the subject of this equation as well, multiply both sides by a and flip the sides, we get h equals a times the sine of b. Right? So look, we found h in terms of b and angle A. Here we found h in terms of side A and angle B. These two equations, we can put them together and say, well, if h is this and h is also that, this must equal that. And we get this, b times the sine of A is equal to a times the sine of b. Right? That's logic. We like to have the a's together and the b's together. So if we switch this around, divide both sides by a, then divide both sides by b, we can rewrite this equation like this. Once again, you can pause the video if you don't trust me, if you don't see it immediately. But apparently, the sine of angle A divided by side A, which is opposite the angle, is equal to the sine of angle B divided by its opposite side. We can use this to find missing angles, missing sides. We could switch this around depending on what we're trying to find in a problem. We could also state it like this. Right? If we go from here, divide both sides by sine of A, divide both sides by sine of B, we would get this. Right? These are just two different shapes, really, of the same rule, the same equation. Okay, so this is the sine rule, written like this or written like that. Apparently, the proportion between the side and the sine of the angle opposite the side, that proportion is equal for all of the three angles and their opposite sides. We could add on to this and say side C divided by the sine of its opposite angle is also in the same proportion. It is also equal to that, right? Let's see how we can use this cool new rule in actual triangles like this one. This is oh really, my paper's stuck. This is a real triangle where we have we know two angles, we know one side, and we need to figure out what the length of this side is. Now, one cool piece of advice is when you are trying to find a side, it is easier to use this shape of the formula, of the equation. When you're looking for an angle, it is easier to use this form of the equation. So we're looking for the length of this side, so we're going to use this form of the equation. A divided by sine of angle A is equal to side B divided by the sine of angle B. Of course, we're free to label any angle as A or B, as long as we call the opposite side corresponding letter. All right. Okay. So when we plug in the values that we know, let me see here. Yes. When we plug in the values that we know, we, side A is equal to, I don't like red. Side A is 18, so apparently 18 divided by the sine of 104, 5, is equal to side B, which we don't know what the length is, it's x, divided by the sine of B, so the sine of 42. Yep. We multiply both sides by the sine of 42 to get sine of 42 times 18 over the sine of 105 is equal to x. All right, we grab our calculators and plug this in, and we find that x equals, when we round it, 12.5 centimeters, because here we're working with centimeters, right? So we used, we were trying to find the length of a side, so we used this shape, this form of the equation, which I copied down here, plugged in the numbers, the angles, and the lengths of sides that we knew, and solved for x. I have another example triangle. Where is it? Oh, here. In this case, we're trying to find an angle. This angle is unknown. It's x. So we use the other form of the equation, which is this one. The angle is on top. So let's copy that down. Sine of angle A divided by side A is equal to the sine of angle B divided by side B. All right. Let's call this A and side A. We'll call this angle B and this side B. When we plug in our numbers, here, the sine of A, so sine of 25, divided by side A, 6.2, is equal to the sine of angle B, which is the unknown, sine of x, divided by 4.8. We multiply both sides by 4.8. 4.8 times the sine of 25 divided by 6.2 equals the sine of x, right? So then to get x by itself on one side, we have to take the inverse sine of this entire thing. So, and I like to have x in the front, so I'm going to do that. Inverse sine of this whole thing, sine of 25 divided by 6.2, voila. And when we plug this into our calculator, and watch your parentheses, very important, we are taking the sine of this whole thing. We're not taking the inverse sine of 4.8. No, this whole thing. We will find that x is equal to 19.1 degrees. Voila. Okay, I think you're ready to do some problems on your own. Good luck.